So friends, now we are discussing the definition of function first. Okay, so first of all we will write the definition of the function, then we will discuss this step by step by drawing the diagram. So please write down the statement. So first is definition of the function. Okay, so please write a function f. So we gave the name of the function is f. So what is f? F is basically a relation between two non-empty set or non-void set. So a function f is a relation between two non-empty set A and B. So a function f is a relation between two non-empty set under such conditions. So what are the conditions? Please write down. Such that each and every element of set A, each and every element of set A has unique image in set B. Okay, has unique image in set B. Okay, so a function f is a relation between two non-empty set A and B such that each and every element of set A has unique image in set B. Here set A is known as domain set and set B is known as codomain set. Okay, so write down here set A is known as domain set and set B is known as codomain set. Codomain set. Okay, so friends, what we learned? A function f is a relation between two non-empty sets set A and set B such that each and every element of set A has unique image in set B. Okay, and set A is known as domain set and set B is known as codomain set. Symbolically, it is represented by. So how symbolically function can be represented? So write down symbolically it is represented by like this. F is a function such that f from A to B. Okay, so f is a function from A to B or f such that A to B. So this is the symbolical representation of the function. A is known as domain set and B is known as codomain set. So please write down how read is. So read as f is a function from A to B. Okay, so we read normally in this way, that is f is a function from A to B, f such that A to B. Okay, so we already discussed the definitions of the function And here we also learned that functions is a relations between two non-empty set A and B such that each and every element of set A has a unique image in set B, and set A is known as domain set and set B is known as codomain set, and symbolically it is represented by f such that A to B, or read as f is a functions from A to B. Okay, here A is the domain set and B is codomain set. Now we will discuss step by step by mapping diagram, that is which type of mapping shows the functions and which type of mapping does not show the functions, just shows the relations. Okay, so let's have a look. So friends, now we are discussing the mapping diagrams through which we will discuss whether a relation between two non-empty set is a function or not. Okay, so please look how we can discuss. Suppose there are two sets. This is one of the set and this is another set. So this set is set A and this set is set B. Okay, so these are two sets. Obviously they are non-empty, that is the elements in set A are suppose small a1, small a2, small a3 like this, and elements in set B are b1, b2, b3. Okay, so a1, a2, a3 are domain elements, that is elements of the domain sets are known as domain elements, and elements of the codomain sets are known as codomain elements. So b1, b2, b3 are codomain elements. Now if a relation f is related such that the image of a1 is b1, the image of a2 is b2, and the image of a3 is b3. So we can say in this way also, b1 is the f image of a1, b2 is the f image of a2, and b3 is the f image of a3. Or we can say by relation f of a1 is equal to b1, f of a2 is equal to b2, f of a3 is equal to b3. Now just we'll think about this relation. Look, each and every element of set A, that is the domain set, has unique image in set B. That is the domain element A1 has only one image, which is B1. Similarly, domain element A2 has only one image, which is B2. Domain element A3 has only one image, which is B3. And every element of the domain set has image. So these are two main important conditions for our relations become function. Okay, so the relation f is function here as each and every domain element a1, a2, a3 has unique image in the codomain. Okay, so here the relation f is a function. So just write here f is function here. Is it clear? So what are the main two conditions for a relation to be a function? That each and every element of domain set must have image. And how many image? Each and every element must have unique image in the codomain. Is it? So these are two important conditions whether our relations become functions or not to identify this. Okay. So let us consider for the another mapping diagram. Suppose this is one of the set and this is another set. Just give the name of this set is X and give the name of this set is Y. That is, element in this sets X are, if we consider X1, X2, X3, and elements of set Y are suppose Y1, Y2, Y3, Y4. Is it clear? Now, just assuming another relation, that is phi, such that the x1 has phi image y1. So phi is the relation, x1 has phi image y1, this refer y1 is equal to phi of x1. Okay. Similarly, x2 has suppose phi image y3, and x3 has phi image y4. Now the question is whether this relation phi is function or not. Here phi is also a function. Why? Because the definitions of function satisfy here. Look, first conditions to become phi is function, what? That is, each and every domain element, that is x1, x2, x3 must have image in the codomain. We have it is x1 has image y1, x2 has image y3, x3 has image y4, is it? And each and every domain element, that is x1, x2, x3 must have unique image, that is only one image for every domain element. x1 has how many image? Only one image, which is y1. x2 has how many image? Only one image, which is y3. x3 has how many image? Only one image, which is y4. So the definitions of functions is satisfied here. That is why the relation phi is also a function in this mapping diagram. Okay, so please write here phi is a function. Now look, one of the important thing here, in this codomain set Y, there is an extra element y2 which does not represents image of any corresponding domain elements. But this does not violate the definitions of the functions, because in the definitions of the functions nothing tell about the codomain element. Okay, so it may be an extra element or more than one extra element in the codomain present. Okay, only two important relations must satisfied, which we already stated in the definition of the functions, that each and every domain element has image, and secondly, each and every domain element has unique image. These two are enough to identify whether a relation is a function or not. Okay, clear? Now consider the third diagram, then it will be more clear to you. Suppose considering another two set, suppose name of this set is E and name of this set is capital F. Okay, here we consider E is domain set and F is codomain set, and elements of E are E1, E2, E3, and elements of F are small f1, small f2, small f3, small f4. Is it clear? Now, let G is a function or G is a relation such that the element E1 has G image f1, that is G of E1 is equal to f1. Similarly, element E2 has also G image f1, that is G of E2 is also f1, and the element E3 has G image f2. Okay, now whether this relation G is a function or not? Yes, in this case the relation G is also a function. Why? Because the definition of the function satisfy here. Look, in the domain, each and every element, that is E1, E2, E3 has image in the codomain. This is the first condition satisfied. And how many image of E1? Image of E1 is only one, which is F1. How many image for E2? It is also one, that is also F1. How many image for E3? It is also one, that is F2. So each and every elements in the domain set has unique image in the codomain. So this is also a function. Okay, so in this case the relation G is also a function. So please write down G is a function. Is it clear? So in all of these three mapping diagram, F, phi and G are functions. Okay, because the relation F, phi, G satisfy the definitions of the function. Now considering another diagram. Suppose these are two sets. Just give name of these sets are again H and K. Okay, so if we consider H is domain set and K is codomain set, and considering the elements in H are H1, H2, H3, and elements of K are K1, K2, K3. Is it clear? Now, just consider another relation, that is psi, such that H1 has psi image K1. So, psi is the relation, H1 has psi image K1, that is K1 is equal to psi of H1. Okay. Similarly, just assuming H2 has psi image K2. Okay, that is K2 is also psi of H2. And H2 has psi image K3 also. That is K3 is equal to psi of H2 also. That is psi of H2 is equal to K2 and K3. And H3 has psi image K3 also. That is psi of H3 is equal to K3. So, the relation psi is defined in this way. Now, whether this relation is a function or not, obviously it is not a function, because the relation violates the definitions of the functions rule. Why? Because here the domain element H2 has two images. The first condition already satisfied, that is each and every domain element has image, that is H1, H2, H3, all of this domain element has image, but the domain element H2 has two images. Look, H2 has images are what? K2 and K3. So, that is why this violates the definitions of the functions, because in the definition of the functions each and every domain element must have unique images. Okay. So, this psi is just a relation here. Here psi is not a function. So, please write down the domain element H2 has two images. Okay, that is why the psi is just a relation, not a function. So, psi is not a function here. Okay, here psi is just a relation. Got it? Now consider another example, then it will be more clear to you. So, let us consider another relation, please. So, these are two sets. Give name of these sets are just as you like, that is capital G and capital H, and capital G has elements G1, G2 and G3. Okay, and capital H has elements H1, H2. Is it clear? Now, just if we declare another relation, that is theta is a relation such that G1 has theta image H1, okay, and G2 has theta image H2. Okay, that is H1 is equal to theta of G1, H2 is equal to theta of G2. Now, whether this relation is a function or not, sure, the theta is not a function here, it is just a relation, because the domain element G3 has no image in the codomain. Is it? That is the first conditions of the definition of the functions already violate here. So, this is theta is just a relation, is not a function. So, please write down here domain element G3 has no image in the codomain. Okay? In the codomain. So, theta is not a function. Here theta is just a relation. Okay, clear? So you understand, I think that is we already cleared through mapping diagram also the definition regarding the definitions of the functions. Now we'll discuss the types of function. So please look.